Ralang kutaka de kutaka da dingina dom dom.
You put a candle and you have water in a trough candle, you put a jar over it, and what happens? Water? Okay, any other thing that you remember about? Is everybody familiar with the experiment? Anybody not familiar with? All of you are familiar, okay. What else do you remember that experiment? Stops burning, excellent. So let me just draw it. So you have a candle and you close it, and after you close it, what happens? The candle goes off or candle stops burning. Okay. Okay. Increases. Anything else that you remember about this experiment? Okay, you infer that being utilized. Okay, we'll come to that. Any other observations that you remember, or just the? Okay, maybe we'll show them the video, but just a 2-second video. Please see there. The same experiment, nothing different. Okay, so is the same observations, or do you want to add to any of the observations?
Smoke coming out.
Smoke, okay, smoke, you see smoke. Okay, you see smoke. That is part of the inference. We are just focusing on the observations.
Depending on the size of the class, it works for more or less.
How do you know that? Based on this experiment, whatever I have shown to you, what is the observation? That's all I ask.
The candle went off only and the water. The candle didn't go off immediately.
Okay. The water level came up and then the candle went off. Okay. The water level came up and then the candle went off. Okay. How many of you agree to that?
I think both happened
together. Actually,
oh, okay. It happened together.
The candle didn't go off immediately. It took some time to.
Okay. So it burned. Before which it went off. But how about the water rise?
and when it was getting off, there was a sudden increase.
So it was slowly increasing, but when it went off, there was a sudden increase. Is that everybody agreeing to that observation? So let me put it this way. So the candle is burning and then water level is rising slowly. Then the candle went off. Water level rises fast and stops, right? Stops at a certain level. Okay. And where does the smoke come in? When? After the candle is put off. Okay. After the candle is put off, there is smoke. Smoke or something. We don't know what that is. Something is coming out. Okay. So, it's what calls for an explanation. So, we are trying to come up with an explanation that explains these observations. Are we on page? Okay. So, what is the explanation? You already said something. Can you repeat it?
Basically put off the oxygen supply into the glass container, and the available oxygen was utilized for combustion. And once the combustion was complete, the oxygen level inside is exhausted. That is the reason when the candle went off, the level raised and it stopped because the smoke, combustion releasing gases that occupied the remaining space that basically stopped the water level from raising.
Okay. So what you're saying is that oxygen or whatever is there is air inside, and air contains oxygen. Let me skip off those steps and say oxygen is there and oxygen is required for burning. And since it is a closed system, correct me if this is not what you say. So since it's a closed system, burning consumes oxygen, and once the oxygen is consumed, therefore to fill in the space, is that what you said? No, you said something else.
To equalize the atmospheric pressure.
Oh, okay, so there is a low pressure that is created. Okay, so inside the jar, low pressure because oxygen is consumed. So to water rises. Yeah? Anything else to change, add, revise? Okay, so the external water level comes down. That is your expectation, but do we observe that? Did we observe that? Okay, so that's the expectation. We'll perhaps we have to do a careful experiment. External water level has to come down. That's the expectation. This is part of your observation, or what should happen. This is the explanation for water level rising inside. That's what you said, right? Now we agreed that these are the observations that we need to explain, right? This explanation, how many of these observations are explained by this explanation? Two. Candle went off. Two is water. The first one or the third one?
No,
First one or the third one?
Why it rises fast is not explained here.
Why it rises fast? So he says why it rises fast is not explained. But does it explain why it rises slow?
The rising is explained, but the slow or fast is not explained.
Okay, why it is rising is explained, why it is slow or fast, and why this particular sequence of events is not given in this explanation. Is everybody agreeing to that? Yeah.
I mean, as a student, looking at this experiment, I would have a doubt like, if the water had the place to come inside the, cup or whatever, then why didn't air come through it and give some more oxygen to make it burn some more time? If the water has the gap to come in, why didn't the oxygen also come through it?
Yeah, that's a question that we need to answer. So you can ask those questions. That's legitimate to ask. But as of now, what we are saying is, this is the observation, and how do you explain these observations? Do you get it? This is what I'm observing. I'm not observing that air is coming inside, or I do not know.
I thought that would be postpone on that question that might be related to these interlinked. It's all interlinked.
Okay, how would you go about answering that then?
Maybe the vacuum of that, which is like trying to consume, that's why the air has to come in, so the water level rises up more
So there is vacuum inside the jar. Okay. So what prevents air from coming inside? There's nothing that prevents air from coming inside, right? Or is there something that prevents air from coming inside from the external environment?
The water fills the gaps.
Okay, so the water prevents the external air from coming inside. Okay, so how does this explain, how does that explain any of these observations? Does it help? 1 minute. We'll come to this explanation. I'm just trying to address her question as why we don't have to take that question first. What our focus is on is in explaining this. That particular question is an interesting question to ask. But
What I'm asking is, will it be related to interlink that with this flow I'm asking? That was my question.
we'll have to try it out and see. And just now we tried out and it doesn't seem to explain the observations.
That's how the sessions, what we are trying to address is like, that's how we have to carry forward the sessions with children.
Oh, you're going on the, let's try to come up with, let's not worry about how we will conduct it with children. Okay, for now, at least for this first 3 hours, we'll have a Q&A session.
Very technical, very concept-based. Different subject teachers are sitting.
Ha.
So now this is getting too concept-based. So let's not beat around the bush and come to the, it's becoming too technical. Not many science teachers are here. So we can't really get into all this.
Yeah, I think it might be useful. What Vignesh is trying to do is to simply ask.
No, I'm with no disrespect.
No, there's no disrespect here. Anyway, here is what we need to explain, and here is a proposed explanation. And your question is, if this explanation were true, there are some further questions. That's the next level. Let's figure out whether this explanation explains this or not. Very basic stuff. And then we can ask, if this were true, what else would you expect? Are those things happening? Why are they not happening, etc.? That's the second order. First level first.
Yeah.
My approach would be to ask very specific questions to each of it. Like, water level rising story, how can I make it rise faster? Or why does it, instead of asking initially why, I would go with the next, create more hypotheses or more questions with respect to individual of them. Like, candle went off, how can I make sure it doesn't go off? Or water level rising at a critical level, how can I stop it initially itself? So my approach would be more experimenting with itself to see if I'm picking it up and see whether it's staying for a long time. So have that part instead of getting into the jargons or the bigger words. And then reason out those hypotheses and figure out whether
Yeah, so you still have to reason out something, right? So that I sort of jumped all those because of lack of time. But I agree that you can take that approach and figure out, when do you, how can you control the rise? How can you make sure the burning is continuing and all that?
to find out what are the various.
Yeah, but at the end of the day, there are a set of observations and you have to explain those observations. You come back to that. Whatever approach you take, you do additional experimentations, doesn't matter. But you come back to the question, these are the observations and how do I explain it? We come back to that. Are we all on page? I understand this is, thank you for pointing it out. I didn't realize that not all would be science teachers, but this is 6th standard textbook stuff, so we assumed it would be easy. Anyway, fine. So the idea is these are observations and we are asking for explanations. And now you have formulated a set of an explanation. Now all that I'm asking is this explanation exactly? It doesn't. Now if it doesn't, which are the observations? Is any observation explained by, any of the observations explained by the given ones? Candle went off is explained, but 1, 3 and 4 we don't know yet. Agree? Okay. And so here you said there is, what did you say? It's a closed system, oxygen is required and burning consumes all the oxygen, and therefore to fill that space because of low pressure or space, whatever you call it, there is water level rise, right? So what would you expect if you put in 2 candles?
It will be faster.
No, but the level. So I don't expect a change.
Okay, so the expectation that she says is the level of oxygen inside the closed system is the same. Agreed?
Possibly the level of the water which might rise to might be lower.
Okay, the amount of, so here's one expectation, the level of rise will be less than single, I'm writing in short, so it will be less. So that is here, amount of smoke that is produced is higher, therefore will be less. That's the expectation. Okay, the candle will go off faster. Okay. What you were saying? Somebody? Will rise more? It will be faster. Okay, here is the expectation. It will be faster. It will be more. The rise will be more. What is the basis of your expectation? Because he said very clearly, because there will be more smoke that will come, therefore the level of water will be less. The rise will be less. Same amount of oxygen, right? It's closed jar.
Yes, it will be quicker.
It will be quicker, but what about the water level rise? What is the expectation? It will rise faster, and to the extent of rise, slightly more. Why do you say slightly more? Because I sort of to him, there will be more smoke. So, I mean, doesn't mean that you have to resonate to me, but you have to give me reasons for your expected observation. Okay. So therefore, okay, that. But why then? It will be still lower, right? Agreed. The candle occupies. Okay. So because of that, the volume of candle that is immersed in the water. So because of that, that volume will be higher. Okay. So any expectations? What will happen? More or less. Okay. It. It rises faster. Okay. So, but is it the kind of same sequence? Like there is a slow rise, candle putting off, and faster rise? You're not able. No. This does not hold. It's faster. I agree. But do you still have a slow rise? Candle puts off, and then a sudden rise. Water rises as the candle is burning. Water comes up. Sorry?
More water was there on the plate.
We'll have to do it and see, but what I'm asking is just the observation from this particular setup. This particular setup, what do you observe? That's all. It didn't go off simultaneously, okay?
Actually, in this assisted condensation seems to be much more obvious.
I don't know what you mean as condensation. I can see smoke-like formation. That much I can see. I don't know what is condensation.
The water level apparently is more, but actually to minus the volume of the tube, the amount of water and air displaced by the candle will be equal to the.
So the volume of candle immersed is the amount of water rise, is what you are saying.
Water part is one thing, and the air part is.
But when you have the water itself, that difference should be there, right? When single candle, without closing it off, a single candle and a double candle, you pour water, you should see the difference, if there is any.
So I think what he's saying is,
When it rises.
because of the candle, there are two candles. The volume of air is less in the second case.
Okay.
That's what he's saying.
Okay.
Right. So then the solution for that to find out will be put two candles in the first experiment, light one candle. In the second experiment, again two candles, light both candles, so that part is taken care of, right? The volume of air will remain the same. So your point is that the volume of air is not controlled.
Do a fair test. So
Yeah.
in that case,
Okay.
Yeah. Okay. So these are things that we will have to explore. For the observation we will pick up is that there is higher rise in water level. Let's pick that up. Now you said, so now if we go back to this explanation, there is a fixed amount of oxygen in the closed jar and that was consumed, and that's the explanation for the rise. Now why is there more water rise? It's as you predicted, ma'am. Fixed amount of oxygen irukka mudiyum. திடீர்னு எங்க புதுசா நிறைய வந்துச்சா? அது கடைசி தானே வருது. ரைஸ் ஆகோட்டு தானே பபிள் வருது. அதெல்லாம் ஓகே, பட் வாட்டர் அங்க இருக்க ஆக்சிஜன் லெவல் தானே ரைஸ் ஆகணும்.
Actually, the water rise is due to the rise of air, not the oxygen. We light the candle, hot air rises up below that. So we light the single candle. Some amount of air rises up. Due to that air, water level is increased. If you lit two candles, more amount of air is rises up. So to replace that air, more amount of water.
So when does that heating take place?
Okay. See, two candles there is more.
Let me.
Is created faster. More amount of air because of that water is forced inside the pump.
Okay, heating is occurring.
There's more heat generated and the low pressure is more.
More heat is generated.
Yes.
I'll come there.
Yes.
More heat is generated.
Yes.
When more heat is generated, what happens?
Yeah.
It is closed jar system. So top. Okay. More of air is on the top. Okay. That's what I was expecting too. Pressure cooker la enna avudhu? Heating happens, the pressure is building. So there's a high pressure system inside, which means the water has to come out.
Water rise and pressure increase both the same. The air rise, pressure increase both the same.
Air rise but pressure kuறையும்.
Eppadi? Close the system la. It will increase. Pressure will increase inside.
No, that is when water is coming inside.
Yes, of course.
Okay, 1 minute, ma'am. Sorry? Pressure increases. That's what is the expectation.
Pressure bring the water inside the jar.
Increase. Okay, we'll hold on that. You were saying something, ma'am?
So that the bubbles is happening. There is no place to actually vibrate down back.
Okay.
So that's the reason.
Oh, okay. Okay, so that's the use. Bubble is okay. So because of high pressure, bubbling. Okay. Interesting. Okay. So bubbles explains. Okay, that bubble explanation is taken care. Now, how do you explain the rise in water? Same amount of oxygen. There's no change in the amount of oxygen in the jar. And you agreed that there is going to be high pressure because of more heat. Agreed. Rate of oxygen consumption is more, therefore the water level rise will be faster. That part is agreed. But on the level அதிகமா இருக்கே. ஒரு கேண்டில் இருக்கும்போது ஒரு லெவல்ல இருக்கு. So let's assume அணைஞ்சதுக்கு அப்புறம் water level is here. When you have two candles, அணைஞ்சதுக்கு அப்புறம் water level is here. So there is a difference.
Because
One at a time, please. Yeah, ma'am?
Oxygen consumption by one candle and two candles making different. That's why
It is not the same thing. The oxygen consumption, what is like used by one candle or the oxygen used by the candles.
எதுவா இருந்தாலும் இங்க இருக்கிற உள்ள இருக்கிற ஆக்சிஜனை தானே கன்சியூம் பண்ண முடியும். ஓ ஓகே, வாட்டர்ல இருந்து ஆக்சிஜனை எடுக்குது. ஓகே ஓகே, வாட்டர்ல என்ன, எங்க வாட்டர்ல எப்படி ஆக்சிஜன் இருக்கு? H2O ல இருக்கிற ஆக்சிஜனா? எஸ், H2O ல இருக்கிற ஆக்சிஜன் இழுக்க பாக்குது. ஓகே, so there is water, there is oxygen in water and it is trying to pull and therefore there is a higher rise. Why did it not happen with single candle? ஏன் அது இன்னும் கொஞ்சம் இழுத்துருக்கலாமே? Sorry?
See, when there is one candle burning, the amount of oxygen that is being consumed is less, so the level is slow. When there are two candles burning simultaneously, the oxygen is suddenly, when it is taken up, maybe
There is shorter duration of time, the pressure,
so the
suction
low
of
pressure makes the pressure sucks.
So do we have low pressure or high pressure? We have to come to settle that, I guess.
Take the example of a hot air balloon. What happens is low pressure inside it rises. Sort of similarly, when there is heat inside, it's low pressure, and the pressure from outside pushes the water inside.
No, I want you to carefully relook. Low pressure, heat ஆகும்போது அங்க low pressure இருக்குமா, high pressure இருக்குமா? It's a closed system and you are supplying heat. So will there be high pressure or low pressure?
If it is completely sealed, then probably high pressure.
இந்த இடத்துல completely sealed தானே?
There is some moving area.
Yeah, but air cannot come in, la. நம்ம air pressure பத்தி தானே பேசுறோம்.
It will take the water inside faster.
Pressure itself brings the water inside the jar. High pressure itself brings the water inside.
High pressure will bring in water inside.
Without the pressure, no water will rise.
Like hot air balloon, the कुछ सीधे तन उल्ला वाला वाटर है.
High pressure இருக்கும்போது எப்படி வெளியில இருந்து உள்ள வரும்? அது you have to settle down. Some are saying high pressure, some are saying low pressure. Hot air balloon. Okay, let's answer this question. உள்ள hot air balloonல நீங்க எதை சொல்றீங்க?
You heat the air inside.
Okay, let me ask everybody, what is your take on it?
I think we keep that pressure concept aside and talk about the balance we want to see.
Right?
New discussion actually when you start about pressure.
High pressure, lighter na? Okay, there are three variables here.
I think there are different groups of people who seem to have understandings of between volume, pressure and temperature. So this is why there is total breakdown of communication among. We have been in order to. One, there is a relation between temperature and volume. Given everything else the same, if you increase the temperature, what do you expect for the volume? It will expand. Suppose there is no scope to expand. The volume is kept fixed. What will happen to the pressure? The pressure will increase. So all else being the same, if you increase the temperature, the volume will increase, or if the volume is kept constant, the pressure will increase. Right? Here, the difficulty with that experiment is that there isn't sufficient water in the tray. Suppose there is enough water, there is a lot of water, so that air cannot get in. Fixed volume. If the temperature increases, what do you expect? The pressure will increase. If the pressure increases, what would happen to the water level? If there is more pressure, more and more pressure inside, the water will go up or water will go down? go down. Is that okay? Okay. Suppose there is a lot of temperature inside the jar and the temperature comes down, what do you expect? But the volume initially was the same, but the temperature goes down. What do you expect if the temperature goes down? Then, okay, the pressure will decrease and the water level will go up. So you seem to have 2 or 3 different explanations for water level going up. One is the oxygen is depleted and so there is less air, so water level goes up. The other is something about temperature, your explanation is not clear. So you have to be clear about what makes the water level go up. Is it oxygen or is it temperature that is causing the change in water level? That doesn't seem to be clear for many of you. So which explanation do you want? Oxygen explanation or temperature explanation? Temperature. So that means the textbook explanation is wrong. Right? Even if there is no oxygen is not relevant, you will see exactly the same thing. So you agree that textbook explanation is wrong?
Not like that. Like say, I'm a 6th grade learned person. Will understand by the temperature way in the initial stage.
Right. So the oxygen is irrelevant, is what you're saying.
Maybe I'll understand.
No. From this experiment, says you don't believe. If you're a 6th grade. Okay. So let's be clear about that. What the textbook says about the water level, you have to doubt the textbook. Okay. So let's just do this step by step. All right? Okay, sorry. I mean, I was looking at the different bodies of knowledge, different understandings from different places, and that was creating a problem.
Okay. So everybody agrees that there is high pressure and there are 2 explanations. One is the temperature explanation. What is there in the book is the oxygen explanation. And as of now, we are not able to give a convincing explanation with oxygen. Agreed? So we have to doubt what is there in the textbook. The temperature explanation. So what you are saying is if the temperature comes down, the water level is going to go up. And therefore, why the water level goes up here is because of temperature. Yeah? No. Okay. What is your explanation for water level going up? Can you come again? Whatever you said. Where are we? Where do you want to start from again? One thing is clear, right? Oxygen explanation we have in the text. The textbook explanation is that oxygen is consumed and a partial vacuum is created. I think these are the words that are used in the book. Please correct me if I'm wrong. The science teachers, do we have science teachers here? Yeah, okay. So there's a partial vacuum that is created and to fill in the partial vacuum, water level rises. That's the explanation that the textbook has. Now that explanation assumes that all of the oxygen is consumed. That's what you said. All of the oxygen is consumed and therefore whatever level of oxygen is there, அந்த அளவுக்கு தண்ணி ரைஸ் ஆகுது அப்படின்னு நம்ம சொன்னோம். ஏன் தீ அணையுது? ஆக்சிஜன் காலியா போச்சு. அப்ப அந்த லெவலுக்கு மட்டும்தான் தண்ணி ரைஸ் ஆகணும். ரைட்? அப்படின்னு பார்த்தா நீங்க 2 கேண்டில் வச்சாலும் அதே அளவு தான் தண்ணி ரைஸ் ஆயிருக்கணும். 3 கேண்டில் வச்சாலும் அதே அளவுக்கு தான் தண்ணி ரைஸ் ஆகணும். Agreed? Are we all same page there? Agreed? எத்தனை கேண்டில் வச்சாலும் ஆக்சிஜன் லெவல் அவ்வளவுதான். அப்ப அந்த கன்சியூம் ஆயிடுச்சுன்னா அந்த அளவுக்கு தான் தண்ணி much only. But that is not what we observe. We observe that when you put in 2 candles, you see a more rise in the water level. And when you put in 3 candles, you will see even more higher rise. Okay? So that is what we are trying to explain. Now, the oxygen explanation that is there in the book is not sufficient to explain these observations. So therefore, we have to look for an alternate explanation. Now, what could that be? That's where we are now.
But in the textbooks, usually we stop with 1 candle.
I know.
Second candle length. So the option is not there.
Yeah. But there is a flaw in that as well.
We don't go beyond that learning.
Okay, since we are running out of time, I will switch on the other gear. So suppose you take this textbook, one candle experiment, okay, and we say partial vacuum is created. How would partial vacuum be created? Because there is combustion going on. When combustion goes on, there is carbon dioxide that comes up, right? So oxygen is taken inside, carbon dioxide is given outside. So where is partial vacuum? Carbon dioxide gets, there is one possible answer. Others? Carbon dioxide varada. Adhe chapter vandu combustion la irukku. Huh? Let's assume that is true, that whenever a compound is saying it, carbon dioxide velila vidudhu. So where is the need for partial vacuum? So even then, ma'am, the textbook explanation.
So the water level should come down then?
Yeah, or at least stay the same. Pressure decrease or increase here. Okay, so you need to bring in the heat. That's what you're saying. So there is heat that is produced when the candle is burning. So what? So the higher pressure inside the jar, so that should push the water level down. But in taking it up, அப்ப அது எப்படி லோ பிரஷர் அங்க வரும்னு நம்ம சொல்லணும் இல்லையா? அதான் மேம், கேண்டில் ஹீட் ஆகுது, க்ளோஸ்ட் சிஸ்டம், பிரஷர் அதிகமா தானே ஆகும். That is what we settled now. அதுதான் நீங்க லோ பிரஷரா இருந்தா மேல வரணுங்கிறது ஓகே. பட் நமக்கு அங்க லோ பிரஷர் வர்றதுக்கு என்ன ரீசன் அங்க இருக்கு? ஏன்னா ஹீட்ல ஆகுது. How is water? I'll take this and then come back.
Like the moment we place the jar over the can, at that time it is heating up, so the pressure will be more, as I said, right? And the moment we place, because of that point, you say that oxygen is required for burning. So when oxygen goes off, the can will lose off, right? And there is a sudden temperature decrease because of that pressure. And then the state comes.
Pressure decreases or increases?
Increases. As sir said, temperature decreases, pressure increases. So at that moment, then the can will lose off, the pressure increases, and then the water comes up.
No, that is not.
No, it's inverse, right? When temperature goes down, pressure comes up.
The volume is constant. You need to keep that in mind.
Pressure comes up. Inside the jar.
Inside the jar, when the candle goes off, temperature comes. Pressure come down. It comes down. So what? Oh, say because it comes down, the water level.
And then there's something, the pressure concept comes in there, and because of that, water is.
சும்மா இப்படிலாம் சொல்லக்கூடாது, தெளிவா சொல்லணும். Okay.
I didn't quite understand the explanation you're giving. This is something that people normally teach primary school students, right? Can you now go back and teach this experiment and give the textbook explanation to students? You are uncertain.
If they are not,
right?
if they are not
They are not questioning, they will say that.
You can tell them anything, right? You can tell them that Earth is completely still and Earth is standing on top of turtles. They will believe it. It doesn't matter. The question is, as responsible thinking people, are you now go and give the same textbook explanation? No. You will not, because you have been thinking. Because you have been thinking, you have started doubting textbooks. And now you are no longer sure the textbook explanation works. Okay? So you now understand that you don't fully understand. Does the textbook try to understand? Let me ask a very important question. Do the people who write textbooks understand science? Not really. So it will be your responsibility to have a better understanding of science, think more about science. The only thing that you have gathered by now is what you thought you knew, you don't really know. That's a fantastic first step. Okay? Once you understand that you don't know what you thought you knew, now you can take steps to have better understanding. You can also help your students to have. We are not going to help you understand it now. Our purpose is to create this discomfort that there is something that you need to learn, and you need to think more carefully before you start teaching. But the first step for us, for our purposes, the first step is fantastic. It's exactly the same thing that happened in the case of the solar system, the Earth going round. Questions?
I'd just like to add one more observation to what Mo said. If this experiment is done in your class, at the end of the year you'll have an exam and you'll have one question saying, candle experiment, what will happen? Multiple choice, tick. Right? Now I just want you to reflect on the extent of learning that you have deprived of your students. Something as simple as this, by just converting it into a knowledge nugget and testing it in an exam, you have closed that box of learning for the child, for the student, forever. And he or she may not have a chance to reopen it. Now, if we do this time and again across all concepts that are being taught in the primary school and in the middle school, are we doing a responsible function as a teacher? Please ask yourself these questions. Pause, reflect, think. What happened as he was unfolding the session? You were discovering something, you were guessing, you were seeing observations, coming up with explanations, alternative explanations, and you were trying to draw concepts from hot air balloons and drawing analogies to see whether you can explain the simple experiment. What all is going in your head is thinking. Right? What you want your students to do is that. But by making it as an exam question, giving them this knowledge nugget and asking, you have killed, at least from the schools that we have seen, we are finding this time and again that the systems that are in place are closing doors for learning rather than opening doors for learning.
We are teaching science as a collection of facts and information, right? But what you were doing right now, without any answers, none of you have answers now, but that is much more like science and scientific research than what we are teaching science as, right? You are teaching it like something that we learn as, this is the fact, this is what we need to know, right? But how did they know that? If we pursue that question with at least some of the facts, we engage in thinking like a scientist would think. And what they need to know is not the facts. It doesn't matter, you know, what how the candle happens and all that. But the thinking that goes through it can be applied anywhere, right? It has nothing to do with the candle, right? So when somebody said that you're not science teachers, right? That is a fantastic opportunity because you have no baggage, right? You don't come with words like, you know, volume and pressure and all that. It's a great opportunity for you to think from scratch. Okay? And if you were shown this, which is very much like a 6th grader being shown something with no baggage of information, how would you go about it? And that is what we want, you know, to have more people enjoy that, because that is the process that is enjoyable. That is the process that is applicable to virtually anything you will teach. Okay? It is because the way you were thinking, you can do the same thing with another experiment which belongs to physics or biology, right? It has nothing to do with the candle, but the way of thinking is common across everything. So I want you to, think about that.
Just to add one aspect more. No, let me just give them, because they are in a state of discomfort.
Sure.
So to reduce the state of discomfort, when you go home,
Don't trust it.
when you go home, think about the following things. One, there are two things to explain. One is the candle going off. The other is water level going up. They don't have to have the same explanation. That is clue number one. I will not give any further clues on that. Clue number two, when you go home, try to do this. Have a pot of boiling water. Put a jar like this, upside down. The air inside will be like this. It will be hot, right? So this is hot air. Okay? Now, have another water. Put this upside down. No candle. Keep it there for some time. What would you expect to find? The water level will go up. No, this is just to make them feel slightly better. Now you go home and work out the explanation for all this stuff. We have given you sufficient clues. We don't normally do this, but because this is Sunday, we are generally a little more compassionate. If this were a regular classroom, no clues. You have to go through it maybe next week or week after that, but we are not going to meet you next week, so we'll give a little more clue. That's it. And now think of what you can do with the students.
Adikta,